Hi, this is Jeff with Sabe, and this is our second video in a series about Sabe and buffer management and DDMRP. In our first video, we talked about master data definition. We had an item, we set that item in sites and assigned to those item sites planning policies and planning categories. However, in this video, we'll be looking at some actual data, live data from a company that's having some problems with buffer management and replenishment policies for its purchase items. So some background information, I've created a planning category, buffer management. We're looking 180 days back in history to determine average daily usage, and we're slicing that history into buckets that are lead time in width to determine standard deviation. We've set up some baseline distribution for purchased and distributed items, and this planning category only includes purchased items. There are no manufactured items in this planning category. So the planning policy, and there's just one at this moment. Planning policy has 1,900 active and inactive items. We won't see 1,900 in the actual displays because 200 are inactive. We're buffer planned. We're considering demand spike at some reasonable level. We have 15 days of average daily usage in the green zone, lead time in the yellow zone. So yellow zone is 100% of lead time usage, and two planned sigmas in the red zone. Now I want you to notice that the buffer profile for this planner code is not set. There is no buffer profile in here, and we'll get back to that in a little bit. So now that we have our items imported, we have our item sites created, we have inventory history for, I think we have 2 years in this system. We'll be using 180 days. We can look at update planning parameters. So I'm going to run update planning parameters for planner category BM. I'm going to update ADU and sigmas and buffer levels. So right now Sabe is going over our 1,900 items, determining which are active, and then extrapolating 180 days of inventory usage, calculating the average daily usage, and then calculating the standard deviation over that period. So we came up with 1,700 active items. We have average daily usage. We have sigma. In the case you see that's very large, we probably need some load leveling or some pull manufacturing to level those sigma levels a little bit. We'll talk about variability when we talk about buffer profile families. But we've created the top of red, top of yellow, and top of green for each of these 1,700 items according to the ADU parameter, according to the analytic history and the analytic resolution in planning categories, and then the relative sizes of each buffer and the planning policy for each of these items. Now you also see we have columns for managed stock, which is floor stock, typically Kanban managed, the minimum order, which comes from a vendor contract in the case of a purchase item, and the order multiple. And you'll notice when there is an order minimum set, then the top of green is the greater of the order minimum, or the actual size of the green zone. In this case, ADU is 0, and a procurement lead time of 7 means that the green zone would be 0, but instead it's 4,000. Now, additionally, we calculate the procurement lead time, which comes from vendor contracts for purchase items, and the routing for manufactured items. The component lead time, which comes from the decoupled lead time from the bill of materials for manufactured items, and the safety lead time, which is a manually injected lead time to provide a little more time buffering. So in this analysis, currently we have 1.7 million somethings of direct inventory value, and notice we use direct and not standard. We're a TOC shop, so operations should be managed with totally variable costs, aka direct costs, and not burden cost. We've created values at top of red and top of green. We can then look at the current direct against top of green, and see that we have 1.085 million somethings excess inventory. That's inventory levels which are over top of green. And at the same time, we have 180,000 or 181,000 somethings below top of red. So here is the bimodal state of inventory. We'll visualize this in a little bit. But we have 1.8 or 1.1 too much of some stuff, and 180,000 too little of other stuff. Now, interestingly, the stuff that we're talking about is inexpensive stuff, nuts and bolts and screws. They can still cause a constraint. you don't have the bolt, you still can't put together the very expensive item. So you're seeing what happens when there is poor buffer management for inexpensive things. You have too much. If there's poor buffer management for very expensive things, you often see too little. So this runs twice every night. The first time it runs, it calculates average daily usage in sigma, and then does a buffer profile family reassignment. We'll talk about that in a moment. And then after that reassignment, it recalculates according to the reassignment, the top of red, the top of yellow, and the top of green. Then Sabe will create the replenishment plan for these items. So every night we have new ADUs, new sigmas, new buffer profile assignment, and therefore a new replenishment plan for every item. Now we do have the option to modify the period in which this runs. So if we have some items with very nervous ADU or very nervous consumption, we can lengthen the period over which this runs to inject a low pass over that. But normally this runs every night. So from that point, we'll take a look at planning policy assignments. But first, I want to remind you that in planning policies, we have one planning policy, BM, that belongs to a planning category, BM, but has no buffer profile assigned. So I'm going to push this over here, and we're going to look at planning policy assignments. I'm going to choose planning category BM. Now, what this is telling me is we have no manufactured items. Amongst the purchased and distributed items, we have variabilities that range from 0, which is probably unused items, to a variability of 775. Now, what does that mean? The variability is the number of sigmas that can fit in 100% of the LTU. We can't just use standard deviation because standard deviation is an absolute quantity. And if we're managing items that have vastly different consumption profiles, such as the easiest case would be a bolt, use one bolt for every 2 washers. So right there you have a 1 to 2 proportion of consumption. So we can't just use the numerical value of standard deviation. What we do is we report variability as the value of standard deviation with respect to lead time usage. And remember our red zone buffers for unrepeatability during the replenishment period, during the yellow zone. So this is the right number to use. And it's really not an absolute number. It's a relative number that we can use to distribute our, to define our variability. But in any case, 0th percentile, 84th percentile is 0. And the 90th percentile is, beg your pardon. The 84th percentile, 3.74, a variability rate of 3.74, and the 90th percentile is a variability rate of 4.69. That means, according to this definition, everything which has a variability of 3.74 and below is low variability, and everything that has a variability of 4.69 and above is higher variability. Now, this is all real time, so as I move this around, you'll notice 2 things. You'll notice that when I bump into the top of low variability rocks down too, so I'll do that. You'll notice that the variability number at 77th percentile is updated as we go from 77th through 78th through 79. The other thing I want you to do is watch the distribution around here. These are the item sites that are assigned to this planning category. And as I increase the definition of what high variability is, you'll see that the distribution of high variable item sites increases or decreases. So this is all done in real time, and in real time you can get an idea of how your current buffer profile definitions distribute across actual item sites. Now, in the same way we can distribute across variability, we can distribute across lead time. The items in this planning category have a lead time ranging from 3 to 16. The 50th percentile is 9, and I can define that the 39th and below is short lead time, and the 83rd and above, which is 13 days, is long lead time. And again, that will redistribute our item sites across the lead time columns. So once I've defined how I want items to be defined as short, medium, and long lead time, and low, medium, and high variability within this planning category, I can save this definition back to the planning category by doing that. That's important because every night, optionally, this utility will run and redistribute these item sites according to this definition right here. So as ADU falls off, as lead time changes due to changes in vendor contracts, or in the case of manufactured item routings, then each item site's absolute value would change, and therefore the distribution amongst the all item sites within the planning category will change. So I've defined a distribution that I'm happy with. I've saved that distribution to the planning category. Now back here you can see we have one planning policy called BM. So what I'm going to do is click this check mark right here, and I'm going to distribute those items across planning policies. So now if I refresh the screen, you can see that Sabe created new planning policies. All these planning policies are defined according to the buffer profile definition. So you can see they're all purchased. That P means purchased. They're either long, medium, or short lead times, or long, medium, or small variabilities. So we can come in here, and if you look at the buffer profile, you can see as I come down across these buffer profiles, the DDMRP assignment within that family is shown. So you can see that Sabe redistributed all the item sites, all the active item sites in this planning policy into new planning policies, each of which have a definition. Now, Sabe will only create those planning policies if it needs to. If we redistribute, we have all 9 planning policies already defined. So if we redistribute with the planning policy assignment tool, then these planning policies will not be recreated, which means that we go to each particular planning policy and we can set up our LTU factors for that planning policy. So in the planning category BM for purchase items, medium variability, medium lead time, actually medium lead time, medium variability, we've set up this LTU factor. So I'll do this. Oops, edit it and do this. But for example, shorter lead time items, I want to have a larger green zone. And for longer lead time items, I want a smaller green zone. Not sure if that's what you really want. But what I'm trying to show you is that each of these planning policies can have their own buffer definitions within them. And then every night when Sabe runs the planning policy assignments utility for this planning category, according to the saved definitions, there's a redistribution across existing planning policies. So in DDMRP speak, we would call these, this is a buffer profile family right here. The reason update planning parameters runs twice every night is now, if I go to planning category BM, now these items are not necessarily assigned to one planning policy, but multiple planning policies. And each of those planning policies has a different, potentially a different definition for the absolute buffer sizes, red, yellow, and green. So the first time we run it, we recalculate average daily usage in sigma. Then we run the planning policy assignments with those new definitions of ADU and sigma to redistribute item sites amongst the buffer profile family. And then this runs again to recalculate top of red, top of yellow, and top of green. So what you're seeing is the absolute buffer profile, buffer sizes being created nightly in Sabe with hands-off using the most recent and live data. Then, with those new top of red, top of yellow, and top of green parameters, we create a replenishment plan. In the next video, we're going to be looking at that replenishment plan and how Sabe uses these values in conjunction with demand spike to come up with a DDMRP and buffer managed compliant replenishment order. See you there.